Section 4.2, writing equations in slope-intercept form. Essential question. How do you write an equation in slope-intercept form when you know the slope and one point on the line? So slope-intercept form is y equals mx plus b, where m is our slope and b is our y-intercept, or where the line crosses the y-axis. First example. Write an equation in slope-intercept form and graph. All right, so first of all, they want us to write an equation in slope-intercept form, which is the vocab word we just wrote down, so y equals mx plus b. So when we're all done, our answer should be in y equals mx plus b form. So now we've got to look at what we're given. We're given a point and a slope. In order to put something in slope-intercept form, I need to have a slope and an intercept. I don't have those two things though. I have a slope and a point. So since I have a slope and a point, I'm going to want to start by putting my equation into point-slope form. So we'll start by putting it in point-slope form, which would be y minus y1 equals m times x minus x1. And then I'm going to go ahead and replace my m with my slope, which is 1/2, my x1 with my x coordinate, which is 2, and my y1 with my y coordinate, which is -3. Now, since it's y minus a -3, that'll become a superplus. Now, if I want to get my answer into slope-intercept form, I have to get y all by itself. So that means I start by distributing. So 1/2 times x is 1/2 x. And then 1/2 times -2. 1 times -2 is -2. 2 times 1 is 2. So that would be -1. Bring down the y plus 3. And then again, to get y by itself, I've got to get rid of this plus 3. So subtract 3 on both sides. -1 and -3 make -4. So now my equation is in slope-intercept form. So we started up here with point-slope form, and then by the time we were done, we were in slope-intercept form. So now I need to graph this. I always graph my y-intercept, which is the number by itself, first on the y-axis. So I'm going to go down to -4 on the y-axis and put a dot. And then my slope is what I graph second. That's my 1/2. So rise the top number, run the bottom. Rise 1, run 2, rise 1, run 2, rise 1, run 2. And then if I want to check and see if my answer is hopefully right, let's go back and look at what we were given. Well, I was given a slope of 1/2, which, yep, that was my slope. And I was given a point of 2, -3. Let's see if my line goes through the point 2, -3. Over 2, down 3. Yes, my line goes through that green dot, which is the coordinate point 2, -3. So I should have done it right. All right, second one. Write an equation in slope-intercept form and graph again. So, reminder, slope-intercept form is y equals mx plus b, but we can't put our equation or our information right into that form because all I know right now is a point and a slope. I don't know a slope and an intercept, I know a point and a slope. So I have to start with point slope form first. So y minus y1 equals m times x minus x1. So I'll replace my m with my slope, which is -1. I'll replace x1 with my x coordinate, which is a -3. So I'll make that into a super plus. And I'll replace my y coordinate, or my y1 with my y coordinate, which is 4. Now I am ready to start solving, or getting it into slope-intercept form. So -1 times x is -1x. -1 times 3 is -3. Bring down my y minus 4. And then to get y alone, I have to add 4 on both sides. So this right here is my answer in slope-intercept form. So I started with point-slope form, and then I got it into slope-intercept form, and now I can graph. So the number I graph first is my y-intercept. That's the number all by itself. So I go to my y-axis and put a dot at 1. And then my slope is -1, which is the same thing as -1/1. So I'll rise -1, run 1. Rise -1, run 1. Rise -1, run 1. Rise -1, run 1. So let's see if my answer should probably be correct. Well, my slope was -1, yep. And my point should be -3/4. So does my line go through the point -3/4? Yes, it does. All right, now we have a couple word problems. So let's look at just the question first. So it says Joe needs to have his car repaired. The parts will cost $145 and the mechanic charges $60 per hour for labor. So number 1 says write an equation to represent the total cost C for H hours of labor. So let's not worry about number 2 yet. Let's just worry about number 1. So number 1, we just simply need to write an equation. So first, let's think about what things I need to write an equation. Well, I know I need to have an equal sign, because that's what the word equation means. When you're writing an equation, you need to have a variable. You need to have operations. So adding, subtracting, multiplying, dividing, and you need to have numbers. All right. So first of all, it tells us to represent the total cost C. So since C is my total, usually that's going to be right next to my equal sign. So this is right here. The C is my total. All right. So for H, hours of labor. Well, let's look back up to the red part. So it says the parts will cost $145 and the mechanic charges $60 per hour for labor. If I think of this as $60 per hour, per in math always means to multiply. So I need to take that 60 and multiply it by the number of hours. So 60H. And then I've got one more number left to use, that 145. The parts are $145 no matter how many hours it takes for the mechanic to fix his car. So Joe has to pay that $145 no matter what, whether it takes the mechanic 1 hour or it takes him 10 hours. The cost of the parts won't change. That has to be $145. So now let's look up here and see if we have everything we need. We have an equal sign, we have variables, the C and the H, we have operations because we have a plus sign, and then we have numbers, the 60 and the 145. So now let's go to number 2, where it says if Joe paid $355, how many hours did it take the mechanic to fix his car? So Joe pays $355. That is his total. So that needs to go in for C, because C is our total. So I'm going to plug in 355 here, and then I'm going to write down the rest of my equation. And they want to know how many hours did it take. So now I just have to solve for H. So to get H alone, I should subtract 145 on both sides. So it's 0, 1. So 210 divided by 60 gives me 3.5. So 3.5 hours of work it took the mechanic to fix Joe's car. 3.5 hours. All right, second one. Grant is ordering tickets for a hockey game. There is a processing fee for each order, and the tickets are $45 each. Grant ordered 6 tickets, and the cost was $285. So number 1 says how much was the processing fee? Okay, so let's think again about what we need to write an equation. We need an equal sign. We need variables. We need operations. We need numbers. All right. So, we know that the total cost was $285. So let's put that 285 next to our equal sign. All right, let's look at what else we have. Tickets are $45 each. So each is kind of like per. And remember we said we have to multiply for per. So $45 per ticket, so 45 times T, but we already know how many tickets Grant ordered. He ordered 6 tickets. So right away, I can plug in a 6 there. And then he also had to pay a processing fee. So it's kind of like on the last problem where we had to pay an upfront amount for the parts. No matter how long it took for the car to get fixed, we had to pay for the parts. Same thing as this, we have to pay a processing fee for the tickets. But we don't know what the processing fee is, so let's just say plus X. So the price of the tickets plus the processing fee should equal $285. So let's go ahead and try to start solving this. So 45 times 6 is 270 minus 270 on both sides. X equals 15. So the processing fee was $15. All right, part B, write a linear equation to represent the total cost for C tickets. So now we're going to look back at our equation for number 1, but make sure that we have a C in it and a T in it. So now we want to write an equation for total cost. So pretend we don't know anything about the 285, and we're going to replace that with the C. Then we pay $45 per ticket, so 45T, and now we know our processing fee is $15. So C equals 45t plus 15. Summary.